So in previous video I defined what is contamination delay and the propagation delay. Let's review that in much more details. So we said that contamination delay is the minimum time from input changes to minimum amount of time from input changes to output starts changing. Okay, so we said the moment from which the input changes to the output starts changing. Now we also noticed the point that, so let us take the earlier example of a NOT gate. Okay, so let us say input is X and the output is Y. So we said if you are giving input, let's say from 0 to 1 at t is equal to 0, the output Y, right? Output Y will not change immediately and it will take some amount of time. So initially what will happen, let us say this is t is equal to 0. So output will be in the initial state for some more amount of time, and then it will start decreasing, right? Because it is the NOT gate, and if you are applying the input from 0 to 1, let us say high input, then the output will start decreasing, but for some more amount of time it will be in the invalid state. We don't know what is that output value, and then finally it will go to the 0. Okay, that is the characteristics of this NOT gate which we defined. So we said this time, right, the moment the output starts decreasing or output starts changing, then this time from t is equal to 0, we will denote it as TCD or the contamination delay. But why we are saying that the minimum time, why we are focusing on the minimum time, let us understand this in the detail. So basically what happens when we are manufacturing so many millions of NOT gate, let us say in the manufacturing unit, right? So no two NOT gates are same. So what may happen, let us say this is our first NOT gate which we have manufactured. So what may happen, it may start, so the output, right, let us say this is X and this is Y. The output Y may start changing, let us say after 1 nanosecond. Okay, so let me make it the characteristics again. Let us say this is our input, okay, and let us say this is the output. Okay, so this is the characteristics we have defined. So let us say the output Y for this, let us say this is our first NOT gate. Okay, so for the first NOT gate, our output Y may start changing after, let us say, 1 nanosecond after time. Okay, now let us say we have another NOT gate which we have manufactured by the same means in the manufacturing unit, and whose input is also X and output is Y. But as we discussed, right, when we are manufacturing these NOT gates in the millions of numbers, no two NOT gates are same. So what might happen, let us say this is input X which we are applying at t is equal to 0. So what might happen that output Y which is changing from initial state to the final state at 0, this time might be 1.01 nanosecond. Okay, so let us say this is our second NOT gate. Okay, similarly the third NOT gate might be having the minimum delay, right, minimum time after which the output Y starts changing. Let us say that might be 1.02 nanosecond. Okay, so in this fashion all the NOT gates which we have manufactured might be different in terms of the time. So now once the manufacturer is sending all these NOT gates to the vendors which are buying these NOT gates, so manufacturer is saying that, look, I'm sending you these NOT gates which are having the different characteristics, but one thing I'm sure is that no NOT gate will start changing, or no NOT gates output will start changing before 1 nanosecond of time, because we can see that all the NOT gates are taking at least of 1 nanosecond of time, right? So the manufacturer will say, see, the TCD for this NOT gate is 1 nanosecond. That means the minimum time which the NOT gate will take is the 1 nanosecond. After that only it will start changing. The output will start changing. So now that means that some NOT gate might take 1 nanosecond or 1.02 nanosecond. But we have defined the minimum time bound on this after which the output will start changing. So that's why we are calling TCD, or the contamination delay, is the minimum amount of time after which the output will start changing. Or let me write it in this way: output will change, or I will say output will start change will be greater or equal to TCD, and TCD we have defined, or the manufacturer has defined, as the 1 nanosecond. Okay. Now similarly we have defined the propagation delay, right? Propagation delay, we defined that maximum time from input changes to output reaches the stable or the final value, right? Stable value. So this is the propagation delay definition we have defined. Now what is maximum in this? So let's take the same example of the NOT gate. Let us take our first NOT gate, and we defined NOT gate characteristics like that. So this is our, let us say, input X, and our Y output, which we are saying that it is taking 1 nanosecond at least before output starts changing. Let us say the output is getting to its final value after 2 nanosecond. Okay. Now similarly for the second NOT gate, we define the characteristics. Let us say this is our input X, and let us say our output Y is taking 1.01 nanosecond before it starts changing, and it's getting to its final value. Let us say this is the time 2.01 nanosecond. Okay. And now let us say for the third NOT gate, this time after which the output is getting to its final value, it's, let us say, 1 nanosecond. Okay. So it is 2.01, it is the 2.1 nanosecond. So now maximum of this, now manufacturer will say that okay, my NOT gates are taking 2 nanosecond, 2.01 nanosecond and 2.1 nanosecond, but one thing I am sure is that nobody will take greater than 2.1 nanosecond. So all the NOT gates will be getting its final stable value within 2.1 nanosecond. Okay. We can write output will take output will take its final value less than equal to 2.1 nanosecond. So the manufacturer will say that okay, my TPD is the 2.1 nanosecond. Okay. So this is the maximum amount of time which will be taken by the output Y to get its final stable value. So now I have made a characteristics for 3 NOT gates which we discussed. Now let us say this first NOT gate, right? This is our first, this is our second, and this is our third, and characteristics are like that. This is our first, this is our second, and this is third. So now if you see the minimum time after which the NOT gate starts changing will be taken by this third NOT gate, right? Because let us say this is our 1 nanosecond. Okay. And this is our second nanosecond. This is, let us say, total is 2 nanosecond, and let us say this total is let us say 3 nanosecond. Okay. So the minimum time after which the output starts changing is 1 nanosecond, right? 1 nanosecond is the minimum time. So the manufacturer will say for the NOT gate by average or by any means, you can say it's not the average, it's the minimum, right? Okay. So the TCD is the 1 nanosecond. Okay. Because minimum time is taken by the NOT gate is the 1 nanosecond. Similarly for the TPD, right? TPD, if you see, this first NOT gate is getting stable at this point, second NOT gate is getting stable at this point, and third NOT gate is getting stable at this point. Okay, so the maximum amount of time will be taken by this second NOT gate. Okay, so let us say this is our 5 nanosecond. Okay, and let us say this time is the, let us say, 4 nanosecond. Okay, and let us say this amount of time taken by the third is the, let us say, 3 nanosecond. Okay, so the maximum amount of time taken by the output by to get its stable value is the 5 nanosecond. So we will say that TPD is the 5 nanosecond. That is the maximum amount of time. So TCD is the minimum bound, and TPD is the maximum bound, which will be taken by output Y to get at least after TCD it will start changing. So till TCD we are sure that output will not even change. Till TPD we are sure that we will be getting its final stable value.